These are the significant figure notes for chemistry. This is a really important concept to learn about, and the reason it is because we'll use it in all of our calculations throughout the school year, and so it's a really important topic. What we're doing is we're finding out which numbers really matter. These include all the digits that are known, plus a last digit that's typically estimated. This is known as an uncertainty digit, and actually it has to do with the precision of an instrument. And so we always read all the known digits, and then we have one unknown. So when you do calculations and you read numbers and things like that, that's where significant figures comes into play, because we don't want to have a bunch of numbers that are just estimated, and we don't want to keep compounding numbers and calculations with estimated numbers. So that's where we use that all the time. All right, so your rules for your significant figures are actually on your formula charts that you're given as well. Okay, so you need to know how to use these rules. You don't necessarily have to have them memorized, but you do have to know how to use them. Okay, the first rule is all non-zero numbers are significant. So any number except 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all significant. So for this first example, 22.4, none of those are 0, so they're all significant. So there's 3 significant digits there, or figures. 6, 9, 4, and 1, all non-zero numbers, so they're all significant. So that would be 4. Now our second rule says that zeros between non-zero numbers are significant. So what I like to say on this one is these are our sandwiched zeros. So if zeros are in between non-zero digits, so for example, we have this 304. Well, 304, the 0 is in between the 3 and the 4, and so the 3 and the 4 are non-zero digits, so that makes 3 significant digits. I was hoping it wouldn't do that. All right, then we have 7002. Okay, so 7002, the zeros are sandwiched, so that makes that 4 significant digits. Now, our next rule is leading zeros are never significant. So leading zeros are those zeros before we get to any non-zero digits. So in this first number, 0.0152, there are 2 zeros before we ever get to a non-zero digit. Those zeros don't count. So only the 1, the 5, and the 2 count. So that means we have 3 significant digits. Then when we have 0.0002, the only number that counts is the 2, because all the other zeros are in front of the 2, or leading zeros. So that's only 1 significant digit. Our next rule is that trailing zeros are only significant after a decimal point and a non-zero number. So if there is a decimal point anywhere in the number, actually, and they come after non-zero digits, then they're significant. So for our first one example here, we have 120. The 1's non-zero, the 2's non-zero, those both count. But that 0 is after them. So the next thing we have to look at is there a decimal point in the number? No, there's not. Since there's not a decimal point in the number, only the 1 and the 2 count. The 0 does not. So this is only 2 significant digits. Now for our next one, it's 0.860. Well, the first 0 doesn't count because it's leading. The 8 and the 6 count because they're non-zero. And then that last 0 is trailing, and it's after non-zero digits, and there's a decimal point in the number. So all 3 of those digits count, including the 0. So that makes 3 significant digits. Now our final one says that all the numbers are significant if they're in scientific notation. And scientific notation is any time we're going to have some sort of a number and then times 10. So anything in front of that times 10 is counted as significant because the times 10 will be to some power. And these are either really big numbers or really small numbers, okay? But they have a lot of zeros in them most of the time, and we don't want to write all those zeros. So we put it in scientific notation to help with that. So right here we have 3.4 times 10 to the fifth. Well, the 3 and the 4 count, okay? And the times 5 is the scientific notation part of it. So the 3 and the 4 are the two of them. So we end up with two significant digits. And then we have 5.20, which is times 10 to the negative 8. Again, this times 10 to the negative 8 is the scientific notation part of it. So all the numbers before it count. So the 5 and the 2 and the 0 all count. So that leaves us with 3 significant digits. Okay? Okay. Hopefully it'll change quickly. Sorry about that. My little thing's acting weird. All right. So here's some examples that are in your notes. I would like for you to pause the video right now, and then I would like you to go ahead and attempt these. Just determine how many significant figures each one of these numbers has. Use your rules. Go back and look at our examples as well to go ahead and figure that out. But I really want you to kind of try these on your own. So go ahead and pause the video right now and take about 2 minutes to figure these out. All right, hopefully that you were given a chance to do that. And so when we look at these examples, 1.2, they're both non-zero digits, so this would be 2. On B, it's 2.0. That's a trailing 0, and there's a decimal in the number, so that's 2. That 0 counts. On C, it's 3.002. Those zeros are sandwiched. The 3 and the 2 count because they're non-zero digits, so all 4 of them count, and that's 4. On D, we have 46,000, and those zeros are trailing zeros, but there's no decimal in the number, so they don't count. So that's only 2 significant digits. In E, okay, we have 2, 3, 4, 5. All those numbers count because they're non-zero. The 0 is trailing after the 5, and there is a decimal in the number, so all 5 of those digits count. On F, 6.02 times 10 to the 23rd, that's scientific notation, so everything in front of the times 10 counts, so the 6, the 0, and the 2 count, and that would be 3. On G, 0.00121, those are leading zeros, and leading zeros never count. So 1, 2, 1 count, and that's 3 significant digits. For H, the 93,043, okay, that 0 after the 3 is sandwiched by the 4, so that counts. And then the last 2 zeros are trailing zeros. There is a decimal in the number, so they count as well. So that would be a total of 7 digits. Okay? So when we talk about exact numbers, these have what were called unlimited significant figures or an infinite amount of significant digits. And so an example would be like a dozen we know is exactly 12. Well, since we know it's exactly 12, we say that 12 is an unlimited number of significant figures. Okay? If we say that there's exactly 29 people in the room, because there's 29 people, then that's considered an unlimited amount because it's an exact value. And we know that for every 100 centimeters, there's 1 meter. That's a conversion factor, and that never changes. So that conversion factor, because it's an exact value, we won't ever use it to determine how many significant figures there are, because we consider that to be an infinite amount. So we don't use that to determine that when we have, and we'll do that later when we convert different values. Like if we wanted to convert something from centimeters to meters, we wouldn't use this conversion factor to figure out how many significant digits are in our answers. Okay, and we will actually do this a little bit later in the semester, but we wanted to make sure we taught you some of this now because we're going to do some calculations in this unit. Okay, so rounding rules for significant figures. If the number is greater than or equal to 5, then the number rounds up, okay, from that spot. If the number is less than 5, and on your notes you need to get rid of that equal sign underneath the less than 5. It's going to round down, meaning you're not going to change the number. You're just going to keep it what it is. This works exactly like you would do your grade if you were trying to figure your average. If it was like a 94.2, well, that just stays a 94 because it's less than 5. But if it's a 94.7, that's going to round up to a 95. Okay? So it's the same kind of rounding rules. So we have several examples here in our notes. So let's kind of talk about that. So if we want to round 65,002 to just two significant digits, we have the 6 and the 5 count. So then we're going to need to look at the third digit. Well, that's a 0. So that is less than 5. So that will not round that up. We'll just keep it the same. So since it doesn't round it up, we're just going to keep it as 65. But 65 and 65,000 are two very different numbers. So when we're trying to figure this out, we need to make sure that we are figuring out how many significant figures we need to keep. And we're going to either drop the rest of them, but like I said, if we drop all those digits, that's 65. I don't know, if someone owes me $65,000, I want 65,000. I don't want 65. So what we're going to do is we're just going to turn the rest of those into zeros. So that's going to become just 65,000. All right. For the next one, we have 61.57. And we want to round to three significant figures. Well, that means that we're going to keep the 6, we're going to keep the 1, and we're going to keep the 5. We're then going to look at the 7. Well, the 7 is greater than 5, so that's going to cause the 5 to round up. So that's now going to make the 61.6. Okay. Now the next one, we have 0.01621. We only want two significant digits. The first two digits don't count because they're leading zeros. So we keep the 1, we keep the 6. Okay, and we keep the zeros even though they don't count, but we keep them there because they're placeholders. And then the 2 doesn't cause it to round up, so it's just going to stay 0.016. You have to keep those leading zeros, even though they don't count, because if you just write 16, 16 is different than 0.016. Okay. Then we have 42.63, and we want to round it to just 1, which means we're only going to keep the 4. Well, the next digit's a 2. The 2 is not going to cause it to round up, so we're just going to round this to 40, or what we call rounding down to 40. Okay, so we're not going to change the initial digit, but we're just going to round down to 40. The other key on this one is that we don't want to put a decimal there. If we put a decimal after that 40, then that 0 counts, and that means that we would have two significant digits instead of 1. All right. So those are practicing and rounding with significant digits and significant figures, okay? There are two other things that we need to talk about, and that would be calculating with significant figures. And so when we're adding and subtracting measurements, we're going to go with the measurement with the fewest decimal places. That's the one that's going to tell us how many decimal places can be in our answer. And by talking about decimal places, I'm just talking about numbers after the decimal. Okay, so when we look at adding and subtracting, we're only looking at our significant digits after the decimal, or only looking at our decimal places. We're not even looking at really significant digits. We're just looking at how many digits are after the decimal in each one of our numbers. Okay, so with our examples here, I'm going to put them all on the screen. Okay, And you guys should have calculators. If you don't have one, you might want to get one. You could always get out your phone calculator if you don't have it in front of you right now, one of the calculators from class. But y'all, we're not ever going to make you do mental math, so there's no reason for you to worry about that. Just get a calculator. All right. So when we're adding these two numbers of 45.756 and 62.1, okay, we're looking for the fewest decimal places. So this first number has 3 numbers after the decimal place. The second one only has 1. So when we do it in our calculator, we get like 107.856. We get all these digits. But we're only allowed to have 1 number after the decimal. So that would mean we're going to keep this 8. So we have to do our rounding rules here, and we have to look at the 5 after it. Well, 5, if it's greater than or equal to 5, it rounds it up. So this 8 is going to now become a 9. So that's going to make this 107.9 is our actual answer. So I would just box that. Okay. Then if we take our calculator, 89.61 minus 43. Well, 43 doesn't have any after the decimal, and 61 has 2. So we got to go with the fewest, which would be none. So when we do our calculator, we get this. So we're going to look at the number in front of the decimal, and then we're going to look at this 6 right after the decimal. That's how we're going to have to round. It's greater than or equal to 5. So it's going to cause the 6 in front of the decimal to round up. So that will now make this 47. Okay. For this next one, if we take 75.263, which has 3 after the decimal, and 1,123.93, which has 2 after the decimal, and we add them together, we get this really long number. Well, we're only allowed to keep 2 after the decimal, though, because that was the fewest. So we keep the 1, we keep the 9. We look at the 3, it's less than 5, so it's not going to change that 1 and 9. And so we'll just leave it as 1,199.19. And then on 90.0, we have 1 after the decimal. 51.1, we have 1 after the decimal. So when we do our calculation in our calculator, okay, and we subtract these two, we're going to end up with 38.9 because only 1 after the decimal, and that's what we've got. Okay. The next type of calculations we'll do will be multiplication and division. And when we're doing any multiplying and dividing of measurements, we look at it a little different, and we look at the measurement with the fewest total significant figures to determine the number of significant figures in the answer. So really we're looking at the overall number and the overall amount of significant digits in the actual values. Okay, whoever has the smallest amount, that's how many can be in your answer. All right. So again, we have some examples here. So I'm going to click them all up on the screen. Again, use your calculator. So if you take 3.43 and multiply it by 6.4253, you get an answer in your calculator that looks like this. Okay, really, really super long number. All right. Well, this first number has 1, 2, 3 in it. The second number has 1, 2, 3, 4, 5. So we go with the fewest amount, which is 3. So when we look at our answer, we keep the 2, we keep the 2, we keep the 0. So we have to look at the 3 right after what we want to keep, and then we got to round. So this is a 3, so it's going to round down, or it's not going to change, which will make our answer 22.0. Okay. Then we have 26.02 divided by 5. And I will tell you, I am putting units with all of these because we're not ever really going to have just numbers. All of our numbers are going to actually have a meaning. They're a measurement. So we do have to keep units with it. So when we're dividing here, again, use your calculator. All right, you get this number. This one has 26.02. All 4 digits count because this 0 is sandwiched. Also, it's after non-zero digits, and there's a decimal in the number. So 4 digits here. 5. Okay, that's 1 digit. So our answer can only have 1. So 5 we keep. The 2 does not cause it to round. So we just keep it as 5 centimeters squared. We then have 45.756, and we multiply it by 1.2. Our first number has 5 in it. Our second number has 2 in it. So our overall answer can only have 2 in it. So when we have 54.9072, I get to keep the 54, but then I got to look at the next digit. It's a 9. since it's equal to or greater than 5, it's going to cause my 4 to round up. Since it's going to round up, that will make this 55 meters squared. Okay. Our next one, we're taking 45.01, dividing it by 2.2. Okay. This first number has 4 significant digits in it because the 0 is sandwiched and it's after non-zero digits with a decimal. And then the second number has 2. So when we do this division in our calculators, we get this, but we're only allowed 2 significant digits. So the 2 counts and the 0 can count because this 4 is not going to cause us to round up. So when we write this, we have to write it as 2 with a 0 and a decimal. Notice this decimal right here has to be here because we want to make sure that the 0 counts. And that 0 won't count if the decimal is not there. And then we'll only have 1 significant digit, which isn't following our rules. Okay, so if you notice I put that decimal there, that's because that's to make that 0 count as a significant digit. All right. Hopefully you understand these significant figures rules. We will be using them all year long. So let's do some practice now. All right, you should have a worksheet to do that.